That's a joke. Don't worry.
Okay, welcome 269 subscribers. I gained 2 subscribers over the last couple days because of my, probably because of my creepy thumbnails. I'm not gonna lie. Okay, so today we are learning about the law of signs, and we are going to learn about the ambiguous case right now, which is really the hardest type of problem involving the law of signs. So when you have a triangle and you're given information in this way, the capital letter is used for the angles A, B, and C, and then the length of the side is noted in the same letter across from it in lowercase. So I've got this angle A is across from this side A, and we don't know either of those. For B, we know that length is 4, and across from it, the measure of that angle is 20 degrees. And then for C, we know the side length is 6, and we don't know the measure of this angle. So we can't, if we know 2 of the angles, we can solve for the third angle by subtracting those 2 angles from 180. So we can't do that here. We also don't have 2 pairs where we have one unknown. Wait, I lied. We do, right? So we go ahead and we set it up. 4 over the sine of 20 equals 6 over the sine of C. And we have one unknown, so we can cross multiply and divide just like we do in our other problems. In this case, we have the sine of C equals 6 times the sine of 20 divided by 4. Since we're trying to find the measure of an angle, back from geometry, we would then use inverse trigonometry to find that. So we go to our calculator.
Wait,
Did I lose you?
no. In the way you wrote it, why isn't the sine C with the 4? Like, wouldn't it be, if you crossed it, wouldn't it be 4 sine C?
Yeah, I didn't write that out.
Oh.
You would write 4 times the sine of C equals 6 times the sine of 20, right? And then you would divide both sides by the 4. And I just did that in one step.
Okay.
So now I have the sine of C isolated, and now I'm going to inverse sine both sides. So I'm going to take the inverse sine of this value here to find the measure of the angle C. Should I explain that again?
Yes, please.
Okay. So here's what I'm doing. This is kind of from geometry. I can't write on the board like that. Oh my gosh.
Spring 2022.
Yep.
Spring 2022.
I hope the tech department sees every time I try to write on the board.
Oh God, it's just.
Did I ever tell you guys about the time that I had a Sharpie in my hand and I went up to the Promethean board and I was just like talking and I just go like that. I just drew a line across and then I was like, oh, it came right off.
Really?
Yeah.
How?
Yeah, I'm pretty sure dry erase markers actually work perfectly fine on boards.
That was a Sharpie.
This is a
though.
TV. You think I could use a dry erase on this?
Yeah, that's
Yeah.
what my science teacher does. He uses the.
He writes on the TV.
Yeah.
We're doing that tomorrow.
No, let's do it now.
He erases it, swipes it off, and it works
Done.
perfectly fine.
Think of the views you'll get.
You guys thank you very much. Thank you, tech department. All right, so if we inverse sine both sides, what happens is this is the only function that undoes sine. So those end up canceling. And that undoes the function, so we have the angle isolated. So on the other side, we're going to take the inverse sine of all of this in the calculator. And I just did that. So to find the inverse sine on the TI-84, you would do second sine. First of all, make sure your calculator is in degrees. So go to mode, and the default is radians. So change it to degrees, if you haven't done that already, which I think we already have. Once it's in degrees, then you can do second sine, because the inverse sine is right above it on that same button, and then inverse sine all the stuff on the other side, which is 6 times the sine of 20 divided by 4. That will give you the measure of angle C, which is 30.87 degrees-ish. Okay, so here's the hard part.
Isn't that,
Let me write that down. Angle C is approximately 36 point, oh wait, what was that?
30.87.
Thank you.
Do all triangles not equal 180? Do all of them equal 180?
The sum of the interior angles in any triangle is always 180. Okay, so if angle C, if we have angle C and we have angle B, then we can figure out angle A by subtracting those two from 180. So angle A is
129.13. Wouldn't it help to not
Okay.
round it, then subtract it?
sorry?
Like if you were to do the not rounded version of the 30.87 and you subtract it
Is
from
it
would be
a
more
terminating
exact?
decimal or is it non-terminating? Wait, let's see.
I don't know, because I just subtracted the.
I would just go ahead and round. That's way too many decimals. Yeah. In pre-cal, we usually round to the nearest thousandth, but here we're just rounding to the nearest hundredth. Okay, so all right, so we'll get to the measure of angle, or sorry, of side A in just a second. But I want to explain something else to you. When the information is given to you in this way, okay, and this is back from geometry. This is angles side. So notice we have a fixed angle, and then we have two sides that we know the lengths of. Okay? We run into a problem because we don't know exactly what the triangle looks like. This is back from geometry, and I'm going to show you a video. You're going to love it.
If we have a set of corresponding angles that are congruent and a set of corresponding sides that are congruent. Okay, so you have two sets. You have an angle followed by two consecutive congruent sides. The issue is with that second congruent side, since we don't know the angle in between the two congruent sides, we don't exactly know its position. So I could take that side and swing it over to a new location and still show that angle side is still the case here, no matter how I choose to draw that second triangle. And I have the option of drawing it either way, since that's an isosceles triangle, so both of those sides are definitely congruent to each other. Now if I draw it this way as an acute triangle, I see that I have angle side, however, the base of each triangle clearly are not the same, and these triangles clearly are not congruent.
Okay, so he was about to show they're not congruent. Okay, so the reason I'm showing you this is back in geometry, when we were trying to prove triangles congruent, and we came across this information fixed in this way, we just said, these triangles are not congruent, we're done, okay? However, now, we know a little bit more. We're in pre-calculus, okay? And what happens is, so here's the angle, here's the side, and here's the side. This side, this 4, could swing over and it could be here. It's possible, okay? So because of that, we have to check the supplement of angle C and see if that works to form a triangle as well. If the information is given to you in this way, angle side, you have to check the supplement of angle C once you get it and see if that forms a triangle. Sometimes it doesn't. Sometimes it's way too big. It's like 192 degrees. And you're like, well, the sum of all the interior angles has to be 180. So you just cross it off and it doesn't work. And you solve it like you would all the other ones. Okay? Sometimes you'll have no triangle. Sometimes you'll have one triangle. And sometimes you might have possibly two triangles. So let's try this one. The supplement of 30.87. If I subtract that from 180, I get 149. So angle C could also be 149.13 degrees. And in this problem, and that could work. That could make a triangle because if angle C is 149 and angle B is 20, we could still find a measure for angle A and make a triangle. So because of that, we just have to solve this problem twice. That's the only thing that makes it harder. So now we have to say, all right, C could be this, so here's what the angle A is, and here's what the side A is, which we haven't found yet. Or C could be this, so now we can also find, based on if C is this, what's the angle A, what would angle A be, and then what's the side length A. That's it, that's the hardest part. It's not too bad, right?
Where did you get 120?
I took the supplement, so I did 180 minus 30.87, and I got that value. Because, and it didn't really show this in the video because it's more for geometry. Gizmos does a very nice job of showing these two angles. These two angles are actually supplements of each other. This angle and this angle, this are supplements. So we found one of them, so now we just try the supplement to see if it also makes a triangle. If the supplement does potentially make another triangle, then we have to solve each of the triangles and say, if angle C is this, then these are all the rest of the values that are unknown. If angle C is this, then these are all the other unknowns. But now it's just like the other problems we did. All right, so an angle A.
Isn't that 129.13 then?
Did I? Oh yes, thank you. 129.13. Thank you. Excellent, excellent. And then this angle A is. Make sure you're checking my work. 10.87 degrees. Last thing we need to do is find the side A. So I'm going to do A over the sine of A. And 4 over the sine of 20 degrees. Why not? And then here, A over the sine of A equals 4 over the sine of 20. So here our A is 129.13, right? And here our angle A is 10.87. Are you guys okay with how I wrote that?
Yeah.
So in the calculator, this is your unknown, this A. So you do 4 times the sine of 129.13 divided by the sine of 20. And here you'll do 4 times the sine of 10.87 divided by sine of 20. So this side length for A would be approximately 9.07. And we have that triangle solved. And this one would be 2.21. That's it for my video.
Okay, that's okay.
Thanks for coming out.